Welcome back, everyone. Today we're going to be jumping into a 12th grade topic, finding the derivative using the chain rule. As always, if there's any questions, feel free to put them in the comment box below. If you have questions about your own homework you'd like to see on this channel, remember you can visit me on Facebook at Tutor Sempai and tell me all about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share with a friend. Well, without further ado, let's talk some more about the chain rule. So you might be asking yourself, what is the chain rule? Well, the chain rule is quite honestly just the rule used to find derivatives of composite functions. If you have no idea what a composite function is, no worries, I actually made a video on this. But for a quick refresher, a composite function is just a function of a function. So normally you have like a g of x or an f of x. But a composite function will take something like this and say f of g of x or g of f of x. A function of a function. That's what a composite function is. In order to find the derivative of this composite function, we need a special rule because we have something else going on. It's not just our regular functions. And that's where the chain rule comes in. So before we get started, let's start first with a little visual to kind of help us understand what the chain rule does for composite functions. So let's say we have this egg. This egg will symbolize our composite function. And what I mean by that is, it's a function of a function. Our outside function would be the egg. Our inside function will be this chapstick. What the chain rule will have us do in order to find a derivative of this is first take the derivative of the outside, the egg. And to symbolize that, we're just going to take the top off. So whenever we take a top off, that symbolizes a derivative. So you notice the top is off the egg, so we took the derivative of the outside, the egg. However, our cap is still on our chapstick. So we don't do anything with the chapstick. It still looks the same. However, we're not done. In order to finish this derivative, we have to multiply by a derivative of the inside. So we have a derivative of the outside, no top, with the inside still the same, right? Times the derivative of the inside. Notice the top is off. This will symbolize our chain rule. And this is how our composite function can find its derivative. Derivative of the outside function, leave the inside alone, times the derivative of the inside function. Now that we've seen our visual, how does this look like with formulas? So let's say we have h of x, right? H of x is our function. Well, this h of x is going to look like f of x of g of x. So our h of x is actually a composite function, right? In order to find h prime of x, the chain rule will tell us, like our visual said, find derivative of the outside, leave the inside alone, and then multiply that by the derivative of the inside. This is quite honestly your chain rule. Derivative of the outside, leave the inside alone, times the derivative of the inside. So we've seen our formulas and we had a visual to kind of understand what's actually happening. But when do we actually use the chain rule? How do we know when to use it and when not to? If you remember, we said the chain rule was the rule used to find derivatives of composite functions. So if you know that a function is a composite function, that's a pretty good indicator that you're going to use the chain rule in order to find a derivative. Let's look at a few examples and see if we can tell when to use the chain rule. So let's say we had this function. Would we want to use the chain rule here? No, this is not a composite function. How about this function? Is this a composite function? Yes, it is. Let's go a step further. Can we tell what are the functions that make up this composite function? So if this was f of g of x, what would f of x be? And what would g of x be? Well, f of x would be the outside function, right? So that's simply x squared. G of x would be the inside function. So that's going to be x plus 2. So you see, we actually do have a composite function here. And because we have a composite function, we can use the chain rule. Let's look at a few more. Can we use the chain rule for this one? No. Although it looks like we have two functions here because we have these parentheses, there's only an x here. We need to have something more than just x in order to use our chain rule. So this, I would say, no. Don't use the chain rule for this one. How about this one? Would you use a chain rule for this? Yes. So if this is f of g of x, what are f of x and g of x going to be? Remember, f of x is our outside function. So the outside function is going to be 1 over x. That's what's going to pretty much shape the overall function. Our inside function in this case is going to be x squared. So by using these two functions in this fashion, we get this one. Hence, we can use our chain rule. This is a composite function. Let's look at one more. Can we use a chain rule for this? Yes, you actually can. So what would be our functions here? This one might be a little tricky. We actually have 3 functions here. The chain rule is not just limited to 2 functions. You can have composite functions where it's f of g of h of x. And if this is the case, you're going to need to be able to find a derivative of this as well. And that's where chain rule really shines. You can find derivative of composite function. It doesn't matter how many functions you have. It's going to follow the same rule. Derivative of the outside times the derivative of the inside, and you kind of keep going. So this would be so if we have a composite function made up of 3 functions, we can break it out in this fashion. And that's exactly what we have here. This is a composite function of 3 functions. So what are f of x, g of x, and h of x equal to? Well, our overall shape, our f of x, is going to be 1 over x, right? This is what's shaping the overall function. This looks like a 1 over x. Our secondary function, our g of x, is going to be what shapes our bottom, our denominator. And this looks like x to the 4th. If we were to just substitute g of x into f of x, we would get 1 over x to the 4th. So that's how we're starting to paint this picture here. Last but not least, our h of x is going to be whatever's inside our g of x, right? So we're going to say x squared minus 2x minus 5. When we have these 3 functions, we can make up our composite function, thus use the chain rule to find its derivative. However, just because you can use a chain rule doesn't mean you should use a chain rule, because there are some cases where the chain rule increases the amount of work you do. Not only that, you might be able to simplify some things before using the chain rule, thus removing some work you have to do as well. This is one of the cases where you can use the chain rule as it is, as it looks, but if you do a little bit of tweaking, you might save yourself a few steps. So instead of writing it like this, if you notice, you can write it like, and if you do this, instead of a composite function of 3 functions, you actually have a composite function of 2 functions. This would be the function f of x, g of x. F of x would be x to the negative 4, and g of x would be x squared minus 2x minus 5. And if you did that, then this would be a composite function of only 2 functions, instead of a composite function with 3 functions. It'll give you the same answer either way, but you have a little bit less work to do if you tweaked it a little bit before you actually did the math. Let's see a quick example of something you can use the chain rule for that you actually don't even have to. If you have a function like this, although this is a composite function and you can use a chain rule for it, this will give you a 1 for the derivative inside the function. If you know your inside function is going to give you a 1, you can almost get away with a shortcut of just doing the derivative of the outside function. So, just to show you, this would be f of g of x, right? Where f of x equals x to the 5th, g of x equals x plus 1. And if you were to do the outside function derivative, you would get 5x x to the fourth, right? F prime. But if you were to do the inside function derivative, g prime is simply 1. So when we do our f prime of g of x times g prime of x, you get what's f prime? 5 of g of x instead of x, x plus 1 to the fourth times 1. And obviously that times 1 doesn't do anything, so we can drop it off. And you notice this is simply doing a derivative of the outside function. You may save a step if you can see shortcuts before you do any real math. However, if you're not comfortable doing that, I recommend doing all the steps and it'll naturally fall out by itself. After seeing a few functions and talking about this for a little while, you may have noticed that the chain rule can go by another name. The outside-inside rule. And it may help you remember the order in which to do things. So if someone says, hey, the outside-inside rule, no, they're just talking about the chain rule. Our example says we have y equal x squared plus 4x plus 6 all to the 5th power. Let's see, are we going to use our chain rule? Yes, our chain rule is going to be necessary because this is a composite function. We can say y equals f of g of x, and f is going to be our outside function. So what is our outside function? As you're just starting this process and you're getting more familiar with how to do this, I recommend breaking it out this way because it's a simple substitution at the end of the day. If you can break it into its parts, find the individual derivatives, that might save you some headache at the very least, so you know all you're doing is the basic math of finding simple derivatives, and then you're plugging and chugging to get your final answer. So f of x and g of x, let's find those first. F of x is going to be our outside function. So what's the overall form of our function here? That's going to be x to the 5th. And our inside function is going to be x squared plus 4x plus 6. So I recommend, now that you know f of x and g of x, let's find their derivatives. F of x is going to use the power rule. If you haven't seen that, I have a video on that one as well. G of x is also going to use the power rule. So now we have our two derivatives. And we already talked about the formula for the chain rule, which is, so if we take this and we plug in our respective functions, we'll get our answer. So f prime of x is this 5x to the 4th. So we do 5, and instead of x, because it's f prime of x, this is f prime of g of x, we're going to plug in g of x into our f prime. So instead of that x there, it's going to be x squared plus 4x plus 6. And we're going to have our 4th power. Then we're going to multiply that by our g prime of x. So where's our g prime of x? That's this. So it's times 2x plus 4. So you may notice we did a derivative of the outside function, we left the inside the same, times the derivative of the inside function. You can leave it like this, or you can simplify this. That's up to you and your teacher if they want you to do any more work, but this is our answer for our question. I hope you're able to follow along today's example. Remember, if you have any questions whatsoever, put them in the comment box below. You may have noticed that the chain rule actually requires some other knowledge before you can really take advantage of it. And that is of composite functions. So if you're not quite familiar with composite functions, the chain rule might be a little tricky for you. You also have to be familiar with the other derivative rules, such as the power rule and the quotient rule. I actually have some videos on all those topics. If you need some refreshers, go quickly check those out and come back if you had any questions about those things. If you have a question about your own homework like I see on this channel, remember you can visit me on Facebook at Tutor Sempai and tell me all about it there. If you haven't done so already, remember to leave the like, hit the notification bell, smash the subscribe button, and share with a friend. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Sempai.